guys, good evening. Hope my voice is clear and audible.
Hello, good evening. Yes, your voice is clear.
Recording is already started. Okay, so someone can you just quickly summarize what was discussed yesterday? Just tell the topics.
It was the linear regression formula. You have started the mathematical formula you
Sorry?
explained. The mathematical formula you explained of the linear
Okay,
regression.
okay. So any other terms do you remember? So someone
And
can also add on.
I cannot add on things because I haven't gone through the recording, to be honest. Today I didn't get time.
Okay. Okay. Okay, fine, it's fine. But please go through.
Yes, I will. Tomorrow is weekend.
Yeah. Yeah. Saratan, Pooja, Priyanka, Deepa, please add on to the please try to add on the topics which was discussed yesterday. Nobody wants to add. Pooja there?
Sir, good evening, sir. Am I audible?
Yes, Deepa.
Good evening, sir.
Yeah.
Actually, yesterday we were saying about the regression, linear regression. What is the the relationship between the dependent and the independent value is called a regression,
Very
and yeah, and linear regression is like we saw about what is slope, what is intercept, how we can define through formula, and
Is Deepa voice is
le-
breaking for me? Is it for others as well, or someone can confirm? Or from my side network issue?
It's clear.
Priyanka?
Her voice is clear.
Okay, thanks, Priyanka. Then my side is the problem, I guess. Okay, Deepa, please continue.
so you were teaching about the slope and the intersect and the formulas related to that. But the last session I just missed it because I had some internet issue. So
Okay.
what I observed
Okay.
from the yesterday's class.
Yeah. Okay. So to add upon Deepa's points, Deepa's summary, what she has described, I just want to add upon the main functionalities of the main components we discussed about the loss function, cost function, and also we have discussed about the partial derivative with respect to slope and with respect to intercept. So dou MSE by dou M and dou MSE by dou B or dou C, whatever it is. Okay, so in today's lecture, what we are going to see is we are going to see the mathematical calculation of linear regression, followed by, if time permits, followed by its implementation in Python. I want everyone to pay much attention. See guys, and again I'm iterating, if you understood linear regression very well, it will be very easy to learn the other algorithms. I can also tell linear regression is a foundation you are putting it for your building or the basement. So if it is strong, you can able to understand other algorithms very well.
Okay, sir.
Yes. Okay. So this is a mathematical infusion. Deepa, I'll share the material post today's class. I think you pinged for this.
Yes, sir. I'll check it once again, sir. I checked it. It is not there. But
Yeah.
still I'll
It's
check
not
it.
there, even I checked. Sorry, it's my mistake.
Oh.
Means I'm handling two classes, right? So I am getting confused where I share them.
Okay, sir. Okay. Thank you, sir.
If possible, Deepa can help me in uploading the documents, whatever I'm giving in a Google Drive, and if you give me a link, it would be easy. If you get time, I'm not forcing you to do.
Okay, sir. Okay.
Okay, so guys, please listen here. X is equal to np dot array, and we have 1, 1, 1, and 1.2, 2.3, and 3. I'm sharing my screen, right?
Yes, we can see your screen, sir.
Yeah, sure. So what I'm trying to tell is basically I have a data set something like this. I have X and followed by Y. 1.2, 2.3, 3.4, 4.5, 5.6, 6.7. Okay, this is the data set I actually written in a programmatic way. NP means numerical Python, which is basically the NumPy library. Dot array. Under NumPy library, we have the concept of array. And you might be asking, what is that 111? I'll tell what is the usage of that 111 later point of time. Just consider right now 1.2, 2.3, 3.4 in the independent variable, and corresponding dependent variable for 1.2 is 4.5. For 2.3 is 5.6. For 3.4 is 6.7. So the programmatic way, whatever I written here, this is the representation. Understood?
So how we are getting this 4.5, 5.6
Yeah,
in
these are
the
all just
place of
some
4?
random values. I'm just taking some random data set.
Oh, okay.
As if this is a data set which you are basically going to train the model.
Okay. It's just
You
an
just
example
there
that
is
you are
no,
giving.
yeah, some there might be relationship or no relationship, but right now don't consider about that. But you want to understand mathematically how it is being solved. So for that I've just taken a small data set which is consist of 3 rows.
Okay.
First row, second row, and third row. This is independent variable. You can consider this is square feet and this is the price also. Just for an example sake. Okay.
Okay, sir.
So if you guys see in the down the initial parameters, I have taken theta is equal to np dot zeros of x dot shape of 1. I know it is difficult. What I have written np dot zeros x dot shape. What that x dot shape gives you guys? What generally shape function gives you? And also mention one. We have seen this in pandas shape.
Details of the data, like
No, it gives me the rows and columns which is present in my data set. Okay, means the number of rows and number of columns in the data set it gives me. I'm telling not about my data set here. I'm telling only x. So I'm only talking about the x dot shape. This here, if you guys see, I have indexed it. So 0 represent rows. Here also I can say 0 and column. So 0 means it is representing rows. 1 means it is representing column. If you guys go to the data set, in the original data set, how many rows and how many columns are there in X?
two columns, 3 rows. Am I correct?
So you should sell 3 cross 2, correct?
Yeah.
So first is the row, second is the column. So this what will be the answer of this? X dot shape of 1. This is 0, this is 1.
2.
Sorry?
2.
4.5.
Yeah, exactly. So np dot zeros of 2, correct? So this entire thing we got the answer as 2, correct?
Yes, sir.
Now in NumPy library we have different functions like zeros, ones. If you say zeros of 2, it will create a list with 2 zeros. If you say zeros of 100, it will create a list with 100 zeros. 0, 0, 0 with a comma separator. If it is ones, it will create a list with 100 ones. So what will be the final answer of this? 0, 0, correct? Agree?
Yes, sir.
So if you guys look at, I have written the output as theta is equal to 0, 0. Fine?
Yes.
Okay. Next, the learning rate, I have taken alpha is equal to 0.01. I'm not going to tell what is that right now. Just remember it's one of the variable. I'm storing some value called 0.01. And m is equal to len of y. So if you just check the number of values in y, you have 3 values. So m will be storing the answer as 3, correct?
Yes, sir.
But this m and this m is not the same. Okay. This is not actually the slope. I should have used some other variable. I'm sorry. So just as of now, just forget about that m. Just leave. Come to the main calculation. Y is equal to mx. The formula is what? What is the formula of linear regression? Y is equal to
mx plus c.
mx plus c. Very
C.
good. So I'm taking m is equal to 0 and c is equal to 0.
C is equal to 0.
Okay. So that's why you could see now here, there is no variable called c here because it is 0. Okay. Yesterday I told m will be replaced with theta 1, c will be replaced with theta 0. Here c is equal to 0. That's why there is no variable called c here. The first step is predictions. X is equal to, predictions is equal to x dot theta. So what is x? X you have it here, 1, 1.2, 2.3, 1, 3.4. That is what I written in a matrix format. Dot. So this dot, the dot operator in vector, you would if you come across mathematics, there is a concept called vectors. In that if you want to do a dot operation, you'll be using this dot, followed by the theta. So what is the theta we have? 0, 0. So you'll be transforming the matrix according to the requirement. Whatever I written, this is clear, guys.
Yes, sir. Clear.
When you want to do a matrix multiplication, there is a rule. The number of columns in the first matrix and number of rows in the second matrix should be equal. So what do I mean here is row 1 into column 1, row 2 into column 2. So these should be equal. The number of columns in first matrix and number of rows in the second matrix. If it is equal, the resultant matrix, the output matrix will be row 1 into C2. So if you guys go here, if you guys checking the number of rows and columns, you're getting 2 cross 2, which is same. So the output matrix, if you guys do the matrix multiplication, you're getting this output as 0, 0, 0, which is also following the rule of 3 cross 1. We have 3 rows and 1 column. Any doubt?
So can you show me how we are getting this 3 into 2 and like you have written at the bottom of the matrix? Can you please write it down and show us?
Well, what do you want me to show?
Now how we are getting this one column with 3 rows with the value of 0, 0, 0.
That is matrix multiplication.
Okay.
If you guys multiply 2 matrix, what you'll get 0, 0, 0, because the matrix, the B matrix is 0, 0. So anyway, the output matrix also will be 0, 0, 0. Okay. Do you want me to do that? And
No. I will practice by myself. And
yeah, you try to check it. If not, you reach out to me.
Okay, sir. Thank you.
So the first step is over. See, this is the predictions. Yesterday I was shouting, right, in MSc formula, mean squared error, y cap, some prediction. So for 1.2, you know the answer is 4.5. For 2.3, you know the answer is 5.6. For 3.4, you know the answer is 6.7. Means there is some relationship with this independent variable versus dependent variable. When it is 1.2, it is 4.5. Okay. But your algorithm is predicting 0, 0, 0. Okay. So then we are having too much deviation, right, guys? Correct?
Yes, sir.
So I should calculate how much is the deviation, basically the error, which I was telling in the MSE formula. Summation of I is equal to 1 to the power m y minus y cap, the whole square, right? So the formula for error is y cap minus y, or you can write y minus predictions. Anything works out, not a problem. So the predictions is the output in the first step, 0, 0, 0. Okay. Minus y is your true value. So whatever the true value, 4.5, 5.6, 6.7. If you guys do the basic matrix subtraction, you'll get minus 4.5, minus 5.6, minus 6.7. Okay.
Yes, sir.
Going to step page number 15. Then the third step is calculating gradient. Okay. So the gradient formula is 1 over m into x transpose dot errors. So I was calculating the len of y, right? That m will be used here only. Okay, we'll keep it 1 over m aside. We'll concentrate on this x transpose dot. See, this is the mathematical notation, x transpose dot errors. If you wanted to do the same in a programmatic way, you have to write like this: x dot capital T means transformation dot errors. So if I wanted to transpose my x, so after transforming, it will be like this. Rows will become columns, column will become rows. X transpose I did into errors. This errors you got it in the second step, correct? Minus 4.5, 5.6, 6 points. Okay.
Yes, sir.
Yes.
Yeah. So now you guys again check for the number of rows and columns following the matrix multiplication rule. Then go for calculating the matrix and then just do the matrix multiplication. And finally, you're ending up with this value, minus 16.8, minus 44.95. Okay. So the formula is 1 over m is there. So only we calculated this part, if you guys know. So now I have to bring this concept here. So 1 over m. So m is 3, which you have calculated previously. And this value. So what I will do, I'll just divide 16.8 by 3 and 44.95 by 3. So after division, I'm getting this answer. Okay. Gradient means yesterday we were discussing, right? Dou MSC by dou M, dou MSC by dou C. These are these values. 5.6 is dou C value, minus 14.98 is dou M value. That is what I'm trying to tell here is dou MSE by dou M and dou MSC by dou C. So this is some minus 5 point some number, minus 14.98 some number. I don't know. This is also part minus 5.2. Some value. Fourth step is now actually you have tried with m is equal to 0 and c is equal to 0. You're getting too much deviation, correct? Your cost function is very high, correct?
Yes, sir.
So now what you have to do, you have to change your m and c and try. So theta is equal to theta minus alpha into gradient. Okay. So theta is this value, the 0 and 0. You guys remember this theta, which we have calculated in the first step, which I was telling np dot 0, np dot zeros of x dot shape of 1. You guys remember, right?
Yes, yes, sir.
Minus alpha. Alpha I also defined, right? ALPHA alpha is equal to 0.01. the same value, 0.0, into gradient, whatever you got in the third step. So if you guys do basic matrix subtraction, addition, something, you're getting finally 0.056 and 0.149. So now your new value for intercept is 0.056 and for slope is 0.149. So your equation will be something like this: 0.149x plus 0.5. I guess 0.5, right? 0.5. So what you will try to do again, you will feed one by one x values: 1.2 first, 2.3 and 3.4. One by one you will be passed. You will get a new values. You will check the predictions. Then you check the error. Then you update the gradient. And then you'll be keep on iterating this step one time. You'll be getting one slope and intercept values. You'll be keep on doing this. Okay, got it?
Okay, sir, but till how long we have to keep on implementing the values for MNC?
Yeah. So until unless your loss function or the cost function is very minimal, because your algorithm is learning now. You
So
already
till
know.
that time, we have to do the prediction, right, for MNC.
Sorry.
Till that time, we have to implement the value for MNC to get the relevant, the exact value. We already have it in our hand, right? Till that time, we have to implement the value for MNC.
You have to
We
basically
are,
run a for loop 1,000 times or
okay.
2,000 times or 3,000 times until unless you're getting low MSC.
Okay, till we get the low MNC.
Got it?
Yes, sir.
Because you cannot do any change with respect to X or Y because it is given by the client. The customer, the customer reached out to you with the inputs X and Y and asked you to build the model. You cannot just ask the customer to change input and output because this is the values it's being generated in their application might be. When the requirements given by the customer, can you ask the customer to change?
No.
We want the customer satisfaction, right? At the end, then only you'll get the profit. Correct?
Correct, sir. Correct.
Think in that direction. So you have to, because the customer is not aware of ML, machine learning. If he is aware of why he is going to reach out to you, you are an ML engineer or AI engineer or data scientist, whatever you can. So he's reaching out to the X and Y. You cannot go and say, sir, I'm not able to find M and C best value for the loss function is not reducing or the cost function is not reducing for a data set. That is your job. Maybe you can ask for some more amount of data to him or some more amount of features to him. But at the end goal, you have to build a model. Correct?
Yes, sir. Understood.
Yeah, I'll show the implementation part. Just a minute. I'll close in some time, maybe in 20 minutes. I'm not well actually, so I'm unable to take the class. Sorry. Even the next session I gave, I told no class, but for you guys, I'm just taking today. Guys, did I discuss about one not encoding and label encode? No, right there.
No, sir.
Okay. You guys remind me and take it. But what I wanted to teach on machine learning, linear regression. So whatever we did in theoretical part, we are going to see in the programmatic way. That's all. Now, if you guys clearly understood program theoretical part, the mathematical intuition or the calculation, now it will be very easy for you guys to understand the program. So if you guys see the libraries which have imported, you guys are aware of. First is NumPy library, numerical Python. Second is pandas. I hope you guys are aware of what is pandas and why, what are the functionalities of it. The third is matplotlib.pyplot as PLT. With matplotlib is used for the visualization part. Fourth, from scalar.preprocessor, import standard scalar. We learned about standard scalar and min-max scalar. Here I'm using the standard scalar. Okay. pd.read means pandas.read underscore csv. So I have a CSV file, the file name called advertising CSV, which has the columns called TV, radio, newspaper, and sales, which has 4 columns in it. Just remove this unnamed 0. This is basically the index column. You can ignore it. As of now, consider 4 columns. I'm going to consider sales is my dependent feature, means the target variable or the outcome variable. The TV is going to be my independent variable. Right now, I'm going to show you guys how single variable, single independent variable versus the dependent variable. As a task, you guys can take all 3 independent variables, TV, radio, newspaper versus the sales. I'll also try to help for that. But right now, let us concentrate on only these 2 variables, TV and sales. So drop in, if you have any missing values, you can drop that roster or something. That all you guys are very aware of. If you guys see the x is equal to df of TV dot values. So I'm in x, I'm going to take in mathematical intuition, I just taken some random values 1.2, 2.2, 3.4. But here we have the real data. So in y, I'm going to take the sales, df of sales. Any difference you guys can see between x and y? Yes, no. Am I audible?
So
At
you
least?
mean to ask like output of the x and y values?
No, not the output of x and y. The representation which I have written.
Yeah, I see in the line TV you have used 2 square brackets.
Yeah, so that is what I wanted to impute to us. So in TV, if I would say TV is also only one variable, say this is also one variable. But for TV, I use 2 square brackets, which means TV expects, the algorithm expects independent features in a multi-dimensional array, but it expects the output variable in a single dimensional array. That's what I mean to say. Just a minute.
So please explain that once again.
Yes, yeah, just a minute. Stop the sharing. Okay, I'll explain again. Sorry, I got interruption. Okay, what someone you asked me?
Like you told that it is going to take the input as a
Multi-dimensional.
multi-dimensional. Okay.
So
And then
if you see here,
yes.
this is the x values only.
Yes.
But okay, before that, you see the standard scalar. I called the class of standard scalar. I created an object called scalar. Scalar.fit transform. I hope you are aware of all these, right?
Yes, these functions like it will transform the matrix into like fit transform.
Yeah. So this all, if you guys see, if you see print x scaled, so the original values was some 230, 44, 70, 151.
It
After
is,
scalar update, it has been changed. But if you
yes,
see, for each value, I'm making one list, correct?
right.
That is what multi-dimensional array I was telling.
Okay. Thank you.
And okay, x scale dot shape of 0. So what is the x scale shape of 0 now, guys?
Like shape of 0 means the
Shape gives us rows and columns, correct?
yes, rows and columns, right? So it will display the scaled values after deriving it.
No, that is print x scale. That is done. This part is done. We have completed. Now I'm in this line. In this line, what I'm trying to tell, x scale shape of 0. First shape will give you rows and columns. This is what I also mentioned here, correct?
Right.
And it will give me the number of rows and the columns the x scaled. So if you guys check, there are 200 rows and 1 column in the x scaled. Okay. Out of that, I'm only concentrating on the rows, not on the columns. Okay. So shape of 0 represents the rows. So what will be the output of this line? The highlighted line.
It will be 200 then.
Exactly. So if you guys go here, you guys can see the answer is 200. I'll explain why I'm doing all this. If you guys see in the next step, if you guys see, x scaled is equal to np dot c underscore np dot once x scaled dot shape of 0. What is this answer? Just now we have calculated. What is this answer? Whatever I highlighted?
200.
200. 200. Very good. I'm telling np dot once of 200, correct? So this is what this np dot once is applied on 200, correct?
Right.
What will be the answer then?
The values which will be
With the list with the 200 ones, correct?
right. 200, like only once. 200.
Like you will be getting like this. N kind of a list with 200 ones like this. 200 ones will be. Now, comma, x scaled. What? These are the x scaled values, right? Correct?
Yes.
So, I have in one list, I have 200 ones. In another list, I have the x scaled values. There are some values, okay? Some 0.1 something. Before that, I'm using np.c underscore. np.c underscore means NP is a numerical Python library, means the panda is the NumPy library. C underscore means concatenation. In programming languages, you would have seen string concatenation. You will, if you use the plus operator in Python, hello plus world, if you write it, it will give hello world. Basically, it adds the two strings together. So finally, your output will be something like this. Same output. Before this, for every value, it added 1 comma 0.9, 1 comma minus 1.7. So now we are basically bringing it to the form, whatever you have discussed in the theory. Correct? In theory also, we add the inputs like this only, right? 1 comma 1 comma 1 comma 1.
Yes.
Got it?
Yes, sir.
Actually, this program will work. I'll give you guys, you can try it out.
So one doubt.
Yeah, please.
That line that np dot once will only extract the output with the 1 values, or it is displaying 0 also. That I'm confused. Np dot one
Where someone?
this one x scaled is equal to np dot c underscore np dot
np dot c underscore.
Okay, it is concatenating as well.
Yeah, it is taking first value from here and first value from here and making 1 comma some 0.1. Next the second value 1 comma 0.5 or something like this.
Okay. Thank you. I thought that it will only extract out the one values. Okay, and it is
No.
concatenating along
Now
with
you
that.
understood, right?
Yes, yes, yes. Thank you.
And also, even if you guys forget, I have given a clear explanation in each cell in a comment section. By taking each part, what it is working, how it is working, and I also taken small matrix and I also explained. So kindly go through.
Sure.
Now print x scaled dot shape of 1. Now what will be the, previously it was 200 comma 1, the shape of x scaled. Now it has become 200 comma
2.
2. Very good, because we have two columns. So now x scale dot shape of 1 answer is print, it will print 2, right?
Yes.
Yes.
So theta is equal to np dot zeros of x scale shape of 1. So whatever you did in the theory, in theory you created a same, right? The same structure has been followed in theory also. So print theta, you will get a 2 zeros. They have defined compute cost is one function, gradient descent is another function. I'll explain one by one. So same like in theory, I have defined alpha is equal to 0.01. Iterations is equal to 1000 iterations. Means the number of times you are going to run this. 1000 times you are going to run. Then theta cos history is equal to gradient descent. I'm calling the function. That function takes 5 arguments. Sorry, 5 arguments. One is x, the independent feature, y value, the sales values. The theta is 0 comma 0, and followed by the alpha is 0.01, and the iterations is 1000. So function will be invoked. So the function call has come here. The same like in theory, whatever you did, m is equal to len of y. So here will be the output will be 200. So cost history is equal to np dot zeros of iterations. So depending upon the number of iterations, you are going to create a list with that many number of zeros. So 1000 zeros, you are going to create a list with 1000 zeros. Agree? Till this point, any doubts?
No.
For I in range iterations. So for I in range iteration means iterations value is 1000. So it will run from 0 to 999, correct?
Yes.
Yes.
That
Yes.
also I clearly mentioned here. Okay. So the first, what will be the first I value?
0.
0.
So predictions is equal to x dot theta. What? So if this step 1, this is step 1, this is step 2, step 3, step 4. Whatever we discussed in the theory. Try to check it out. If you guys have any doubts with respect to step 1, step 2, step 3, step 4, please tell me. Next, I'll proceed with the cost history line.
Why we are writing as x dot of theta in like
So
can't
when
we
you
write
want
as
to do a dot operation, right, with in vector, if you wanted to write in a mathematic programmatic way, this is the syntax.
Okay.
I don't know, someone or Deepa. So 4 steps are clear.
Yes, sir.
So cost history of I is equal to compute cost x comma y comma theta. So I am calling this compute cost function. So now what it will happen, it's basically something, it's going like this. Cost history of 0 is equal to, because I is equal to 0. Compute cost function is called with x comma y comma theta value. So compute cost function is called m is equal to len of y. Predictions is equal to x dot theta. We have discussed yesterday the cost function 1 over 2m into y minus y cap the whole square. So whatever I'm telling programmatic way, that is what represented in a, so it's a theoretical way, that also represented in a programmatic way. The square is the whole square we write, right? That is np square. We do the summation from I is equal to 1 to m. So that's why np dot sum. Okay.
Yes.
So
Okay, sir.
yeah. So initially when you guys take m is equal to 0 and c is equal to 0, you have already x and y values. You are getting now with the model y cap values. You will check the difference between these two values. So y minus y cap, y minus plus y minus y cap plus y, maybe you can square y minus y cap. So like this, you will have 1, 2, 3. You will have for 200 things. Sorry, this is minus. This is whole square for the 200th value divided by 200 into 2. That is what written, right? 1 over 2m. I'll get some cost value. That cost value will be returned to the function call. So now in the place of 0 was there initially, this 0 will be replaced with the cost, whatever the cost value has become. Maybe 4,322 is the cost. That 0 will be replaced with 4,322. So I is equal to 0, iteration is over. Now you might have updated m and b value in the step 4. Now you'll go for I is equal to 1 with a new equation. Okay. Understood?
Yes, till now it's clear.
Yeah. So over a period of time, after 1,000 iterations, I'll discuss these things. If you guys see the graph, so this is the iterations, number of iterations. So 0, 1, 2, 3, 4, 5 till I'm going to do 1,000 iterations. I have drawn the graph here, guys. Please pay attention to this graph. When my in the first iteration, when my I is equal to 0, my cost value is too much higher. Then after certain iterations, the graph you can see it is basically coming down. At the 200th epoch, means at the 200th iteration, the graph has become steep. Maybe it is 199 or 198 or 200th iteration, whatever it is. The graph has become steep. There is no change in the cost function after that. Correct? Maybe it is some 0.06 something. Maybe 59 is there. Okay, you can consider 0.0581 or something. So that has become, after there is any change with respect to the cost value, the iterations are keep on increasing. It is going 201, 202, 203, 204. It is keep on running. But cost, you guys see any changes?
No.
No.
Exactly. So what you are able to infer from this? After 200th iteration, the cost has become same value. So can you guys think of something what has been achieved here? Not to say achieved. Why how the cost function becomes same after 200 iterations? Can anyone think of something?
Is it because of the normalized data, like it has reached the
Sorry. Come again.
Is it because like we have reached the normalized
What
data?
is it actually?
Hello?
Saman, what you're telling, Saman? Please come again.
Am I audible now?
Yeah. Please.
It is because of the, like, we have reached a value where the algorithm is giving the output as desired, like normalized form of output.
Exactly. So what I'll just put it in a very technical term. The algorithm is converged. That's all. So the algorithm has found a best slope and best intercept value for your data set at the 200th iteration. If your slope and intercept is not changing in your linear regression equation, anyway the cost will not change, correct? Because you're getting the same cost after 200th iteration means the slope and the intercept is not changing.
Yes.
Got it? That is what I'm
Yes.
trying to explain here. Okay, I'll keep it here. There are few more things, which is the metrics. Maybe I'll explain it on next class. Till this point is very clear, guys. Or any doubts?
So it is clear, sir, but we need to work out from our side to get more clear picture on these formulas and derivations.
Exactly. So
Yes.
please
So if you could,
spend time.
share with us, like we will practice all the things whatever you have so far
Okay,
taught us.
not at all. Not at all a problem. I'll share all the materials.
So yesterday's material also, please.
Yes, sir.
Okay, yesterday materials you guys wanted.
Yes, we want to like let us the basic concept should be clear.
Yeah, sure. I'll share it. Maybe I'll try to share if
Thank
my network is stable. Else I'll share it by any cost.
Sure.
And apart from that, if you guys have any doubts, I would have continued and completed, but my health is not allowing. It's not allowing me. I can say I'm unable to like talk for so much time. It's paining a lot.
Get well soon, sir.
Sorry.
Get well soon, sir.
Sure. Anyway, I'll complete your syllabus. Don't you?
Like we are going to cover all the topics of like all the algorithms, right? In ML app.
Yes, every algorithm mathematically followed by implementation part.
Okay, and those like decision trees and all. There was one like I was just going through that. One tree implementation is also there, which you haven't like mentioned it while we were discussing unsupervised learning. I
Might
don't
be,
remember.
but I'll teach, but don't.
Okay, sure. Thank you.
I might don't take this. The thing is, I take AI for the next batch and ML for you guys. I'm a bit confused which topic is covered, which topic has to be taken at.
Okay, are you going to take AI for us also?
What are you going to take?
AI for us, AI course for us also?
Yeah. I'll only be the tutor because
Okay, thank
you
you.
don't you want I stop the recording, right?
No, like it would be great if you will teach us.
I thought you were expecting a new tutor.
No, not at all.
What to do with this tutor? Anyway, I'll only be teaching. Don't worry.
And like, what should we skill with the related to the tools related to data science for the like?
No, only if using the Google Colab, that is more sufficient.
No, for practicing these algorithms, we can take the data set from Kaggle itself, or is there any other site also
Kaggle.
from? Okay. And we can showcase those in our portfolio for like for applying some to some companies or other.
Yes.
Okay.
I didn't share the pandas as well, right? This is not the IPONT file. Okay, I'll share the remaining. I've shared only the PDF as of now. I'll share the remaining materials as soon as possible. Is that fine?
Yes,
Okay,
sir.
Yeah.
Okay, guys. If you have any doubts, please post it. I know Deepa Lakshmi has a lot of doubts.
I've already posted, sir.
Deepa, I'll try to answer it in next session for you, sure. Okay, else I will set up a separate session also and share clear all your doubts. Don't worry.
Okay, sir. Thank you.
You can keep adding your add on your doubts.
Okay, sir.
Others also please come up with the doubts. I'm very happy to take the questions. If I complete my ML's course, I'll conduct one Q&A session like to know how much you guys have learned.
Okay.
Okay.
Okay, guys. Thank you.
Thank
Happy
you,
week.
sir.
You.
We'll meet on Monday.
Sure.
Sure, sir.
Bye-bye.
Thank you.
Bye. Happy weekend.
Bye.
Yeah.